Welcome everybody to the Arcserve webinar. We're going to be talking about Linux primarily today, as the title of the presentation, Rise of the Penguin. We've done a lot of stuff actually in UDP 6 to really improve Linux support, make Linux almost as functionally, in fact, as functionally strong, and in some areas even better than Windows that we have in UDP already. So I'm just going to quickly go through the agenda. We're going to talk a bit about UDP in general, what it does and how it works. And when we're going to talk about a bit of background to do with Linux and UDP, we will talk about what we did in version 5 compared to what we now do in version 6, and how, as it says in the slide there, how UDP version 6 gets its Linux groove on. So we're also going to talk about some of the resources for success and top differentiators as well. So I hope you enjoyed the session, and as Raki says, if you do have any questions, use the GoToWebinar question panel and I'll review these at the end. Thank you. So without any further delay, I just want to give a bit of background about Arcserve. We've been in the market with data protection technology for over 25 years. The first generation of Arcserve, our traditional backup technology, was developed in the early 1990s, and over the course of that 90s decade, it became a leader in the Novell file and print server backup space. Arcserve backup was then further developed in the late 90s and early millennium to support more open system platforms, Linux, Windows, Unix, etc. However, at Arcserve, we kind of recognized that the market was rapidly changing, and about 5 years ago, we set out to build a brand new data protection solution, launched in May 2014, our first generation. And what we've done at Arcserve is made the solution to be delivered in different ways. We have a software-only solution, which is where the product originated from. More recently, we've introduced Arcserve appliances now to provide data protection in a box, where you get a server, a compute, the storage, and all the software integrated together in a single, easy-to-use appliance. And also, we introduced the Arcserve Cloud to provide a disaster recovery as a service platform for organizations looking to reduce costs, but also improve capability for disaster recovery. So that's kind of what we do. And what I'm going to talk about now is an overview of UDP itself. So UDP, as I mentioned before, is a unified data protection solution, and it provides data protection, i.e. backup. It provides integrated replication, so we can replicate recovery points between sites. Also includes high availability technology, which can be delivered in different ways, from a range from virtual provisioning, where we can convert backups into bootable VMs and spin them up quickly. But we also have real-time replication, high availability for Windows, Linux, and Unix environments as well. We also have the ability to archive off the tape and other secondary storage platforms as well. UDP has been primarily designed to protect virtual infrastructure and physical server infrastructure, so it allows you from a single solution to manage both physical and virtual environments. UDP has some really enterprise-class data deduplication capability built into the product, so we call it source-side global data deduplication. And we also provide encryption and compression around the data sets as well. As I mentioned before, we have a provisioning capability called Virtual Standby, and in version 6 we introduced a new provisioning capability called Instant Virtual Machine that allows you to spin up a VM directly from the backup, which is really clever. We've also got instant bare metal recovery on Linux as well, where we can basically right-click any Linux node and say BMR onto a physical server, and we can boot up across the network a physical server and get it to run a bare metal recovery from the recovery point server, and we'll talk more about how that works. And as I've mentioned already, it's available as a software, a pre-built appliance, or in the cloud. So if you take a typical architecture of a deployment, you could have an environment where you've got physical and virtual workloads. you've obviously got Linux, but you will also probably have Windows in your environment. So we would deploy either an appliance or a server, which we call a recovery point server. And it doesn't matter if it's an appliance or a software deployed solution, i.e. you're using your own server and storage and you buy our software. It acts as a global DG target on the network, which we call a recovery point server. Now, when we're backing up virtual infrastructure, it's all completely agentless. So when we're backing up VMware and Hyper-V, we just do all the virtual machine backups through the hypervisor APIs, including Linux. So we can snapshot the VMs and back them up efficiently. As this diagram shows, we've got the ability to offload to tape. We still have many customers that want to use tape technology as a sort of long-term archive of the backup. It's fair to say that over the last 5 or 6 years, the data protection market has generally moved from a tape-based solution to a disk-based solution. However, tape still has its place in the overall hierarchy of things, that if you need to keep certain backup sets with sensitive data for long periods of time, it kind of makes sense to use tape to archive, end-of-month backups and keep them for X number of years, depending on what your overall retention policy is. So we have a lot of customers do that. And when we migrate to tape, we provide the ability to do granular restore straight from tape of files and folders as well. Now, as you start to deploy Arcserve UDP out, it could be you're an organization that's got remote branch offices or different sites that you need to manage, where you've got pockets of IT that need to be protected. And depending on the size of these remote sites, we can deploy either a UDP appliance, or it can even be a virtual appliance where you could have a hypervisor at a remote site, VMware or Hyper-V. You can build a Windows VM and deploy our recovery point server software onto it to protect physical, virtual Windows, Linux servers in that remote site environment. Now, when you deploy multiple appliances or recovery point servers, or a combination of both, we provide integrated replication. So we are very good at replicating recovery points from remote branch offices to your head office, or it could be from your head office to your disaster recovery site, or it could be that you've got 2 data centers and you want to back up data center A and then replicate the recovery point to data center B, and then you also want to back up data center B and send the recovery points to data center A. So again, we can provide bi-directional replication of recovery points between sites using our RPS technology. And we use dedupe around the replication to efficiently move just the unique blocks for each set of logical recovery points taken after every snapshot has been taken in your environment. So we're very good at moving data around. We also have the ability to migrate data to the cloud. And again, this is becoming really popular now, where organizations are looking to reduce cost. They've also been down the road of managing their own DR infrastructure. And the challenge is, when you're managing your own DR infrastructure, it's very expensive. You're having to maintain servers, storage. Every 4 to 5 years, you're having to replace and upgrade hardware as it gets to its end of life. And that's okay if you've got servers working in a production environment where you're getting a good return on investment and the total cost of ownership is managed as part of your IT expenditure. But in an environment where you're spending money on DR infrastructure, often that kit isn't heavily utilized, and the business sees that as not a great investment, that you're having to spend money on hardware that's only ever going to be used in a DR situation. So a lot of organizations are looking at cloud now and thinking, hang on a minute, if I move all my tape management costs of having to send media off site and pay for new tapes, that cost can be offset against paying for a cloud service, that I can actually replicate recovery points in the cloud. And from an operational perspective, it becomes so much easier to manage, because you're not having to get tapes from a tape library and put barcodes on tapes and having to run inventories of bringing tapes back on site, which is very IT resource intensive. So you're getting the operational benefit of reducing the staff burnout, having to manage all these tape management processes, but also it just becomes a much more automated approach where everything just happens and it doesn't require any user involvement once you've set up those initial policies. So there are various cloud options available. There is public cloud, the likes of Microsoft Azure, the Amazon Cloud, and that can come in two parts. You've got the Amazon AWS, which is their compute cloud, where you get infrastructure as a service running in the cloud, and you also get their kind of blob storage, which is Amazon S3, where you can just write data to the cloud with no compute involved. So essentially the way we use cloud is in different ways. We can actually copy recovery points to blob storage in the cloud, or you can actually deploy a recovery point server on a compute node in the cloud and use that WAN optimized replication and dedupe to efficiently upload recovery points to the cloud, which gives you faster performance and better bandwidth control as well. So essentially, Arcserve is a multi-site data protection and a disaster recovery solution. We've got automation technologies to spin up VMs from backups, including Linux, as well as Windows. So if a system fails, physical or virtual in production, I can specify either Hyper-V or a VMware environment as a DR platform and actually spin it up a virtual machine within a few minutes directly from the backup. Now that technology can also work on our appliances. Our appliances have a hypervisor built into them, which we use Hyper-V. So with our appliances, you can actually spin up virtual machines on the appliance itself. So it's not just a backup repository for your data, it's also a provisioning box that you can spin up machines on it for disaster recovery. And the key thing about all of this is it can be managed from a single web-based console, so you can see all the different backup, replication, provisioning tasks all being administrated and managed from a single web console. Now, the way that UDP works under the hood is that we do what we call incremental forever backups, and the benefit of this is it significantly saves on the amount of disk that you need to retain the backups on. If you take a typical traditional backup and recovery solution, typically in most traditional products, if you took a backup exec or a net backup or a TSM, well, TSM is actually probably a bad example, a Commvault, these products are designed to do weekly backups. I know that in some cases you can run synthetic backups, but normally even in a synthetic backup world, you need to take a full image at least once a month. So if you add up the base images plus all the daily incrementals, then having to take another full image, the amount of storage a traditional solution will hold on disk is quite significant. Now, before we introduced UDP, we had a product called Disk to Disk, which uses I2 technology, and that's kind of like the middle column there, where we would take a baseline backup and then we would just capture the incrementals forever. And compared to a traditional product, that was introduced significant disk savings, because once you've got a base image of a server, you don't need to essentially take another full backup again. You just specify the number of recovery points you want to retain on disk. And when we get to that number of recovery points, we start to merge the oldest recovery point into the base data, and then we purge out the expired data from the full set at the bottom. And that process keeps on as new recovery points come in. The oldest recovery points sort of merge into the base data and it purges the data. So it's a good way of saving space. However, with UDP now, we introduced data deduplication on top of I2 technology, which reduces the size of the backups even further. So we get significant data reduction rates when you combine the compression and the dedupe together. We get some very, very high data reduction rates on our customers' backups. And I don't have any slides on this deck, but normally when I do presentations, it's not untypical that we get data reduction rates in excess of 85, 90, 95% in some cases, in terms of what we're backing up at the front end versus what's actually on disk after, say, a month's worth of recovery points are taken. So it's very, very efficient. Now, what we introduced in UDP was the ability to create data protection plans. And this is a completely radically different approach to a lot of backup vendors, because ultimately what we were trying to achieve is that when you're doing data protection, it isn't just about the backup, it's about the whole data flow of getting the data backed up. Then you might want to replicate it off-site, and then you might want to spin it, copy it off to tape, or you might then want to create virtual clones from the backups. So you want to create a kind of end-to-end flow of taking that initial recovery point off a server, compressing it, deduping it so it's optimized on disk. Then you want to replicate it, and there's a series of tasks that you need to go through to get from A to B. It's not just the initial backup. So most solutions, you go in and create a backup policy. With us, we create a data protection plan, which is a workflow. And you can see in this example here that there's 3 tasks in a plan. They've got an agent-based Windows backup plan, which could be a Linux plan as well. Then you can add a replication task, and in this case, they've got a virtual standby task to create virtual clones from the backups. And you can add all these different tasks in, so you've got full control and workflow-driven approach to protecting that group of server data. So, you know, if you want to do a copy to tape, we can add a copy to tape task to the plan. If you want to replicate off-site, we have the replication. And the great thing is that once the initial backup task completes, all the other relevant tasks in that workflow just automatically execute. You don't need to work out, okay, if my backup starts at 10 p.m., what time do I need the replication to run? You don't need to work that out. The product does it itself. So as soon as the backup to disk completes, replication wakes up. It's all on demand because it's following that workflow. So it's a radically different approach. And once you actually get your head around it, it's really, really easy to manage and set up. And it takes a lot of the guesswork out of the whole end-to-end flow of data protection. So it's very easy when you go in to create a plan or modify a plan. You can just go in and say add a new task. You click on the button, and then in the drop down it says what task do you want to add to your plan, and then you've got a list of different options you can add. If it's replication, if it's copy to tape, replicate to a remotely managed RPS in the cloud, or whatever it is. Okay, a little history lesson. Now with UDP version 5, we did have support for Linux in the product, but to be honest, the Linux support wasn't as functionally rich as Windows. So if we were backing up a Linux system, we could only back it up to a share on either a CIFS or an NFS share. So you couldn't say I want to back it up to a data store, which is deduplicated storage in UDP. You have to have a different backup destination to your Windows backups. And that Linux backup destination wasn't deduplicated, it was only compressed. The other challenge we had with Linux is that we couldn't run incremental forever either. So you need to you have to create what we call a recovery set, which is basically a full backup, either weekly or monthly, followed by daily incrementals. And then once that recovery set was complete, it would start to create another recovery set, and then in the policy you could say how many recovery sets do you want to keep on disk. So it wasn't as storage efficient as Windows backups because we couldn't deduplicate it and we couldn't run incremental forever. So also some of the other differences were, yes, UDP for Linux was integrated in the console, the same as Windows, but the way the backups were done, we couldn't do incremental forever. We couldn't add additional tasks in a plan, so we couldn't, for example, say, I want to replicate the Linux backup after it's been backed up to disk, or copy it to tape, or any of those things. And as it says there, you were required to do a full backup weekly or monthly. We didn't have backup to a recovery point server, so no dedupe was available. We also couldn't do file level restore from an agentless backup of the Linux virtual machine. So we could back up a Linux VM and do a VM level restore, but we couldn't recover files and folders on a Linux system either. So you can see in version 5, if you were a Linux customer, it was fine if you're a Windows predominantly customer and you had a couple of Linux servers in your environment, you could probably live with that. But if your environment was a lot of Linux, then obviously that wouldn't impress you too much. So the new features now, we've changed it completely. Linux is essentially the same as Windows, so we can now deduplicate all our Linux backups exactly the same as Windows and share the same backup repository on disk. We also, as it says there, it enables incremental forever backups. We can merge and purge the recovery points into the base image, and we've even got the ability to copy off the tape. Also, in an agentless plan, We can do file level restores. So if we're doing a backup of a Linux VM running in Hyper-V or Windows, we can back it up with no agents deployed on the VM and still provide granular restore of Linux files and folders. We also introduced instant BMR, so we could do bare metal recovery of Linux, which is primarily designed for physical servers, where you can boot up a Linux server. You can use Wake on LAN technology. We'll talk a bit more about that. Power it on over the network using a Pixie boot. When the system comes up, we can then initiate the recovery of all the file systems folders in the system. We also introduced new Linux file system support, so we were getting lots of requests for the FS, which is obviously a very popular file system now in Linux, and BTRFS as well. So those file system formats were added. And essentially, we've also expanded Linux supports in many ways because we support SUSE, Red Hat, CentOS. We also support any variant of Linux actually in a virtual environment, so we can do granular restores and VM level backups of Ubuntu, Debian, and even if you're running, you know, other variants of Linux that we don't support out of the box or it's not on our CDL, we're pretty much, as long as it's a supported Linux file system, we can do granular restore of any Linux VM, regardless of what the OS Linux variant is. As long as it's a supported Linux file system, we can do a granular restore. So now when we're creating the plans, you can see in the top left-hand GUI there, you can add your backup policy, you can add all the various tasks, replication, copy to tape, etc. Also, when you're monitoring the Linux jobs running, you can see now that we're compressing and dedupe and doing all the stuff that we did on Windows on Linux. So it makes it very much feature parity now between Windows and Linux environments. So it's working really well. Also with Linux, as it says there, you know, we compress the data and dedupe at the same time, and we give you an overall data reduction percentage. We tend to get very high compression rates on Linux, which is great. You know, so if you are backing up a lot of Linux systems, you will get very good data reduction rates, typically on Linux environments, and that's what we tend to see. So we can also encrypt Linux backups because we enable encryption on the data store, which is the backup destination on the recovery point server. So it doesn't matter if you're backing up Linux, Windows, or any system. If the backup is going to our RPS data store, it will be encrypted using 256-bit AES encryption. And in this plan, it's showing you that we have two types of Linux backups. We have agent-based Linux. When we're doing an agent-based Linux, it's not really a fully fledged agent that we deploy on every Linux node we're protecting. We set up what we call a Linux backup server, which has our UDP Linux binaries installed. And that Linux backup server is almost like a proxy server, basically. So when we initiate the backups, the Linux backup server will actually inject a change block tracking driver onto the node that's being backed up, which allows us to take incremental snapshots. And once the incremental snapshot's been taken, the data is transferred directly from the agent or the node that's been backed up directly to the RPS. If it's a virtual environment, the backup data is kind of migrated, taking the snapshot hypervisor, but the data flow is by the proxy server. So we do that. So you can see in here we can create an agent-based plan very easily. And again, the first time we kick off a backup, it will always take a full snapshot. And as I've mentioned before, we get very high data reduction rates when we're backing up and compressing. Now, we offered a feature called restore files from a VM backup. And then in this example, it's showing you that there are certain tasks that you need to set up before you can do file level restore of a Linux VM. So by default, if you go into the console, right-click a Linux VM that's been backed up and say restore file, you will get a message saying fail to locate an available Linux backup server. So as a prerequisite to doing file level restore, you need to have the UDP Linux binaries installed on at least one Linux production server or any server, which can be physical or virtual. And that server gets registered into the console as the Linux backup server. Once that's been set up, when you then click on Restore File, it will then open up the file system of the node that you're trying to restore. And what we actually do is, from the recovery point server, we take the volume or the file system that was backed up agentlessly, and it gets mounted onto that Linux backup server, which is like a Linux proxy. And that's what gives us visibility. This web service that you're seeing now in the screenshot is actually launched from the Linux proxy server. It runs a kind of Apache web service. It also acts as a mount point to mount those Linux volumes, so you can browse the folders and files. And this is an example of the root file system, where you can go in and select folders and files and what you want to restore. So it's very straightforward once you've got it set up. You only have to create that Linux backup server once, and once it's done, it will act like the mount point and the web service to initiate granular restore or any type of restore in your Linux environment. Now, in terms of the architecture, we have the console and the RPS server. You then obviously discover the nodes that you want to back up and protect into the UDP console. And we also specify the Linux backup server node, as I mentioned before. That's acting, and that has the UDP Linux binaries installed, and that's really important. So when you download the product, there's a link in the initial setup console that allows you to download 2 Linux binaries. One is a bin file, and one is an ISO restore image that has to get installed. So you typically FTP them to your Linux server, change and mod the permissions, and then run the setup. And it literally takes a couple of minutes to install. But once that's done, you register that node with the console, and you're ready to go. Now, once you initiate the backup, it will deploy the CVT driver onto the node that's going to be backed up. But then the data flow is directly from that Linux node that's been protected directly to our recovery point server, and we will compress and deduplicate the blocks using source-side global data deduplication. We also have the ability then from those backups to initiate bare metal recovery of Linux or instant BMR, where we boot up over the network. And again, those processes are initiated from the Linux backup server node. Even though it's actually, you configure it and kick off the process from the console, that communicates with the Linux backup server node to do the BMR of the Linux system. And this is just a screenshot from the installation. When you run the product setup, there are links to download the Linux binaries in the console. And again, the reason why we do it this way is not every customer has Linux, so when you install it, it makes those Linux binaries available, but you just need to click on the link and it downloads those 2 files off the 2 links. And once they've been downloaded, you can FTP them to your chosen Linux backup server node. And once you've actually installed the Linux backup server, you need to register it in the UDP console. So you just go add nodes, and then you select the category, adding Linux backup server node, type in the credentials, and save, and then it will obviously check if the UDP Linux binaries are installed. Otherwise it will give you an error to say it can see the node but it can't register it because the UDP Linux has not been set up on it. So you need to do the Linux binary installation before you register it. So once it's registered, as I mentioned before, it has a web server built into it. So any command that involves doing Linux granular restore, physical or virtual, bare metal recovery, will involve launching the Linux UI from the UDP console to initiate these tasks. You can also, as it says here, you're connecting to your, selecting your recovery points against the node that you want to restore. You can select them from the list. And then you select your restore machine. So by default, it restores to the original location, but you could type in an alternative Linux system. You want to do a restore to an alternative environment, etc. So it's really easy to set up. And then when you kick off a restore, you you'll see that it has a kind of job status manager where you can see the task running. You can also monitor these tasks from the main UDP console under jobs as well. So all Linux tasks, Windows tasks, you can monitor them from the main console as well, see them run. Okay, so what other enhancements have we made? Okay, so Linux agents and RPS features, as we've mentioned already, we've got the source side global dedupe now, support for merging of recovery points incremental forever. We've got support for instant VM recovery, which allows you to spin up a Linux VM directly from the backup, and also instant BMR to basically do a bare metal recovery of the physical machine and put a Linux image onto it. We've also got support for RPS to RPS replication, so I can back up a Linux node to a recovery point server and then replicate it to a remote recovery point server for DR. We've also got support for bare metal recovery to UEFI partitions that was added into the product as well. Support for archive to tape. We actually call it copy to tape, where we can actually copy recovery points from daily, weekly or monthly Linux backups off the tape. We also added support for pseudo authentication for backup source for improved security. Obviously, in a production environment, nobody wants to use a root account, so we can create pseudo authentication to allow us to have full root access to a product without using the root ID. We also added support for the XFS file system. We also certified version 7 of Red Hat, CentOS and Oracle Linux. We also added support for host-based backups and granular restore of Ubuntu, and Debian was officially certified. But as I said earlier, as long as it's a supported file system from a VM backup, we can actually essentially restore any folder and file, even if it's running, you know, Caldera or any other form of SCO, Linux, Unix. You know, we can support that as well. Granular recovery of Linux VMs. Again, we've added file folder restore from an agentless backup. Also for VMware and Hyper-V. You can also include and exclude volumes in a backup plan. So supports most popular file systems, as you can see there. Now, obviously, we don't support every Linux file system, but we do try and support the main variants that we see used in production environments. Okay, just a quick walk through the instant BMR process. The instant BMR was added, and this is really nice because even on Windows, when we initiate a bare metal recovery of a server, if it's a physical machine, you have to literally insert a USB stick, a pen, USB stick into a USB port, which has a bare metal recovery primer on it that allows you to boot up the system, connect to the network, and then select your recovery points to do the bare metal recovery. So with Linux, we've actually taken that to the next level where we can do unattended bare metal recovery. We can kick off the process all from the console, use Wake on LAN technology and Pixie boot, and it will actually do it over the network. So you can do unattended bare metal recoveries, and it says in there it's ideal for managed service providers and remote sites. So if you need to do a BMR, you can kick it off at a remote site without having to send a resource on site to do anything manually. And all you need to do an instant BMR is you tick a box that says enable instant BMR on the node. We pick up the MAC address either from the VM or the physical server, and then we can use that as a destination ID to connect to the remote system. Then obviously the target machine settings, you can allocate an IP address onto that, either as a DHCP or a static IP address. You put your gateway, DNS, etc., subnet mask in there. And then basically when you go next, you'll see it do a Pixie boot. It will actually connect to the remote system. You'll see the remote system boot up. And basically, once it comes up on the screen with an IP address, and then it basically starts the BMR processes. It's really easy to initiate, and it works a treat. We've got lots of customers doing this, and they really like how easy it is to do. In terms of tasks, there are some differences, however, between Windows and Linux. If you create an agent-based Windows plan, there are different options available when you're adding subsequent tasks. things like copy recovery points, file copy, file archive, which we don't do on Linux. With Linux, once you've created a backup task in a plan, you can basically replicate and do copy to tape of those recovery points from the console. So when you're doing a Linux backup task, copy to tape is available, which is something that we added in version 6, and it's really easy to configure. You just click what recovery points you want to migrate to tape. Is it your daily, weeklies, or monthlies? Some customers may just unselect dailies and weeklies and just do a monthly migration to tape, for example. You then go through all the various streams, your destination, which will bring up your tape library. The schedule you don't really need to complete because it will actually automatically run when the relevant daily, weekly, or monthly backup has been taken on disk. It will wake up and do the copy to tape task. There is a caveat, however, when we're doing a copy to tape with Linux, that we don't provide granular restore of files and folders on Linux migration to tape. We can only just do a raw recovery of the data back to the production environment or to disk. Also, there are, in terms of parity, there are some differences. You still need to have a Windows UDP Console and RPS server. So even if you're a complete Linux customer, you still need to use at least one Windows server to act as your backup repository and console server. It is on our roadmap to develop now a Linux recovery point server. So we are planning to expand that in the future. But at the moment, that's what you do require, a Windows server to act as a backup server and console. UDP agent on Linux cannot be the proxy for agentless plans. So if you're doing agentless backup in vSphere or Hyper-V, you need to put the proxy on the Hyper-V host, or if it's a virtual environment, a VMware environment, you need to have a Windows proxy in the environment, or it can be the backup server itself. There is no file copy archive, file archive tasks with Linux, so we can't copy a subset of the Linux backups based on file types and policies to a separate backup repository or the cloud. But again, this is something that will probably come in the future as we develop more parity between Linux and Windows. There's no virtual standby task on Linux, but we do have what we call instant VM recovery, which allows you to boot up a Linux VM directly from the backup storage to either VMware or Hyper-V. So there are some subtle differences, but having said that, Linux also has features that Windows doesn't have. So BMR boot from Pixie, it says already in version 5, but we expanded that capability in version 6. NFS as a backup destination, we can't do that obviously on Windows. Light deployment, we basically don't need to install it's almost agentless backup even on a Linux physical machine. We just inject a change block tracking driver. There's no sort of thick agent client installed or anything like that. So it's a very lightweight driver that gets added to the Linux node that's been backed up just so we can take snapshots. Instant BMR is new. That's what we added in version 6 for Linux. We can't do that on Windows. With Windows, you have to initiate a USB stick or mount an ISO image to boot the Windows server up for doing a BMR. File level restore back into a VM from an agentless backup is available on Linux, and that's something that we are going to add to Windows in version 6.5. Which is coming out in January. So, and file folder exclusion from volume backup, we've got more filters in Linux available as well. So the stuff in Linux that we do in there as well. So we've also added the ability to search for files or folders in the selected recovery points. We can monitor all the backup and restore jobs from the UDP console. Use schedule to run restores off production hours. You can actually initiate a restore on a schedule, so you can say, I don't want the restart to start till 2 AM when the network is quiet to rebuild a server, so you can schedule that offline. You can also recover extended file attributes, including SE Linux, using the Linux capability as well. So We've also added deployment capabilities, so VM tool or integration service within guest VM is not required when you're doing any sort of backup and restore. We don't need to add a password to connect to the guest VM when we're backing up or restoring. It's pretty straightforward. You do need to enter a session password, but you don't need to enter a user and password to connect to the actual VM itself. Agentless technology eliminates the need for any software installation. That's pretty obvious, but it's really nice. We can do agentless backup across those Hyper-V and VMware platforms. Okay, we're going to talk about flexible licensing options now. We've talked about the technology. So if you are licensing UDP via software, there are different ways to license the environment. We can do per socket licensing, which covers CPU sockets that you are managing your environment on. So if you have a predominantly virtual environment, we add up the physical CPU sockets across all the virtual hosts, Hyper-V, VMware, even Citrix, Xen, or any other hypervisor. We just add up the sockets. And for your physical servers, you can either license on the per server basis, or you can license on a per socket basis across your physical servers as well. So it's a physical CPU sockets. Typical virtual host will have a dual sockets. It's not the number of cores or anything like that. It's the number of sockets on the motherboard that are active. We also have a per terabyte license, which allows you to license the software based on how much data you're backing up. And it's a front-end size, so it's before compression and dedupe. So if you were to do one full backup, what would the size be before we compress and dedupe the data? We also have a per server license for our advanced edition, which is available as well. So that's kind of how we license the software. And then we have different editions. We have Advanced, Premium, and Premium Plus, which allows you to back up Linux and Windows in all the packages. The Premium basically has additional capabilities that we can integrate with hardware for snapshot. It says for NetApp, but we can also do it across Nimble, and we're going to be adding FreePAR hardware snapshot integration in the next release as well. So we're growing out the hardware snapshot support list. We've also got full role-based admin and full tape library support in the Premium license as well. And then the Premium Plus includes our real-time replication for Linux and Windows environments. So you can actually do asynchronous replication of Linux file systems between Linux nodes using the real-time, what we call Arcserve replication, RHA, and that's available under our Premium Plus. You can also mix and match editions as well if you're doing per socket or per server licensing. So you could actually license X number of sockets on Premium or Advanced and X number of sockets on Premium Plus. So that way you're only licensing the software when you need the functionality. We also introduced appliances about 18 months ago. We've been selling what we call the 7000 series up until very recently. In fact, it's still available. The 7000 series has been great for us. We have 6 appliances in our range, starting from a small appliance that can back up to 8 terabytes, which has about 3 terabytes of onboard storage. And our largest appliance was what we call the 7600, which has 30 terabytes of onboard storage. And that can protect up to 90 terabytes of production data. But with the 8000 series now, we've actually created a range that can go from a very small environment all the way up to very large environments. Our largest appliance now has up to 80 terabytes of capacity on it, so we can protect environments up to 240 terabytes of data. Now the new appliances also have a benefit that you can expand the storage. So we have a smaller range of models, but each model has quite a range of terabytes. You have a base, capacity, plus you can add expandable storage into each range depending on which one you purchase. So they're very customizable. You can also add more RAM to the new 8000 series appliances. Now the key thing about the appliance, which makes it really popular, is the fact that as well as getting the server and the storage, you also get all the licensing included in the cost of the appliance. So when you buy an appliance, you can back up as many physical and virtual machines that will fit onto the storage of that appliance. We've also got the Arcserve Cloud, and this allows you to replicate recovery points into a virtual recovery point server sitting in our cloud. And then we can even create virtual we can spin up virtual VMs into what we call continuity server, which is a Hyper-V layer built into our cloud that allows you to spin up the machines and provision them and access them from your production site if you ever have a complete site outage. And that's all integrated into the cost. The Arcserve Cloud is licensed on a 1-year subscription model, and we use a terabyte capacity. The difference is, however, with the terabyte licensing in the cloud, we calculate that on the dedupe size of the data going to the cloud, not the front-end size. So if you're a customer and you are backing up 20 terabytes of data and you had, say, 3 terabytes of backup storage consumed, and you would buy a 3 terabyte license to replicate all that recovery point data to our cloud, and it's licensed on how much deduped and compressed data you send from your data store on your on-site RPS or appliance to our cloud. So it's a really good service, very popular. We've actually sold a lot of cloud licenses in the last 12 months, and our data center is actually in the Netherlands, which is obviously inside the EU, and it adheres to all EU regulations. In terms of recognition, Arcserve UDP has won lots of awards over the last 18 months. In VMworld last year, we actually won a number of awards both in the US and in Europe. In San Francisco last year, we won Gold Award for the best disaster recovery and backup for virtualized environments. In VMworld Europe, which was in Barcelona last year, we actually won Best Disaster Recovery and Virtualization Project for a project we did with a part of the Open University called the MK Smart Initiative, based in Milton Keynes, and that won the Best DR Project for Virtualization Disaster Recovery. It also won Best of Show, so when they actually have a winner of the Winners Award, where they're looking at all different categories, we actually won the Best of Show award as well. So that was really good for us. We also won the Data Protection Product of the Year at the Storage Awards earlier this year, and we're winning accolades all over the place. PCIT Pro, we won Editor's Choice Award with our appliance, etc. So really that sums it up. I know I've kind of jumped around a little bit. I just want to recap a little bit as well. We've talked about Linux now being almost, in fact, in my opinion, in some ways exceeding Windows in terms of some of the cool things that we can do around instant BMR and booting up over the network for Linux systems. We can do granular restore of Linux file systems even from an agentless backup now, which is great. We can dedupe and compress and replicate Linux recovery points off-site. We can copy Linux recovery points off the tape. So we can provide a very comprehensive solution for Linux and Windows environments using UDP. We've also, Linux is fully enabled in our appliances, so you need to protect Linux as part of your environment. The UDP appliance has all the features built in. The Linux server piece that I mentioned as a prerequisite for doing granular restore runs as a VM on the appliance, so you don't even have to set up a separate Linux server in your environment. You can actually run that service on the appliance itself, and that allows you to do the granular recovery, etc. So we believe at Arcserve, Linux is very well represented now with UDP. We've also got scripts and pre and post template scripts to bank up things like Oracle on Linux, MySQL as well, which I didn't mention in the presentation. So we do have a very comprehensive set of features and functions to protect Linux environments now. So I hope you've enjoyed this morning's session. My name is Charlie Smith. I work in the pre-sales team for the UK and Ireland business. But if you want to email me, my email address is charlie.smith@arcserve.com. So it's very straightforward. I hope you've enjoyed the session and look forward to speaking to you soon. Thank you very much. Thank you.